pulled up a quick head here. This is the cleaned up data frame. So got ID column. I do have the targets here. I had to assign variable names because there's no variable names. Start off with a correlation chart. Heat map. I use Seaborn for this, and so we use NumPy to create this mask. I don't like it where it goes over on the other side. I feel like it's distracting, so I don't do that. That one's simple. Some key things here is I unpack the axes into an ax list so I can iterate over it easily. I create bins for my histograms. But essentially what I'm doing is I have 30 variables. I'm going to do 6 plots on each plot, 6 axes on each plot. Gives me 5 plots total. So I'm going to have 5 plots of histograms with 6 histograms on each plot. For p-in range, I did this a couple days ago, so this is the first one, and then I've got I can't even see one whole data visualization here. How are you supposed to do a data visualization here? How are you supposed to make beautiful data visualizations with this Jupyter notebook? You know what I mean? It's okay for quick stuff, and if you want to do like a little blog post, but yeah, no, my first one, this is my second one, 6 through 11. You've got kind of this measure of skew here, median, skewing left. So you got skew, you can see that. Unfortunately, I couldn't keep the x-axis. I do have the value counts fixed, so we're sharing the y-axis. We are not sharing the x-axis. See, it's 0 to 0.3, and this one's 10 to 20. They're just on different scales. Part of the reason why they picked this data set, it's fine. It's not great for data visualization, but it is where it is. Gives you a sense of the actual distribution on this one. And then on the next one, I'm going in. These are actually very simple, quick little box plot here. Box plot worked well. And then, so this is giving you, the box plot gives you a sense of location, right? Like, where are these variables? We've got all 30 variables right here. We know we need to go vertical so that we can fit all 30. We've got these 2 large variables, some in between. Most of them are small. So I go into another one and I extract the ones that are not outliers, but essentially we're rendering a plot with no outliers, but we need to actually pull out the ones that are not. So now you see the x-axis here goes from 0.6 to 0.0 to 0.6, or 0 to 0.6. And this one we're going from 0 to 4,000 because this one variable right here. So this is this data set's just got some interesting features to it. I mean, if you're not a data scientist or you're some hacking it together on the internet, you're not going to know how to do this. You're going to look like an ass. Split the data set. Yeah, so I want to split it 75-25. Usually we're doing the 80-20. I've got 500 records. It's not enough. 20% of 500 is 100. I'm going to have 100 records for my test set. It's not enough. I'm going for like roughly a little bit over 125-ish because we're over 500 total. So but I don't want to hold out too much because then that's going to hurt the accuracy of my model. I would like to have essentially a training set, a test set, a validation set, 3 partition. A lot of people do it 70-20-10, whatever. If I had 10,000 records, I could do that. I can't do that here. I'm kind of handicapped. And a lot of this is just, correlated features. We saw the correlated features up here. We've got correlated features. We need to deal with that. And then we also have like a low number of records, which, is going to cause overfitting because we're just going to be overfit to these 500 records. Obviously, there's more than 500 breasts in the world, so we're going to not be fitting all the other, breast lab metrics properly. Totally lost our amount. Yeah, so I'm splitting here. You'll figure it out. Okay, actually, so I'm doing 3 things here. So I'm splitting here, again, 75-25. I'm also doing principal components. I'm also scaling. And I did this differently initially, but then I changed it. So what I'm doing is I'm scaling all the data, all 500 records together, because I want that scale to be uniform. Then saving them out. So I scale first. Then I'm splitting. So scale... Actually, no, I split first. Split data set. I'm splitting and then scaling. I feel like in my spider that I'm scaling and then splitting. So I drop the ID column. Oh, I bring them back together. Okay. So I'm making the split. First. I bring them back together here. See, I concat them back. Within the fit method, I concat them back together. So because they need to be fit for the scalar together. I'm not, we know this because we're data scientists. They need to go in the scalar together, so they go in the scalar together. They come out of the scalar, and I split them back up again. Oh, okay, yeah, all right, okay. No, I see what it is, all right. So they go into the scalar together, right? Scalar.fit. I concat them together. Then I transform them and scale them separately. Xtrain, Xtest. And I don't need to scale the Y, obviously it's 1, 0. And then here, I have to put them back in data frames because I'm just having a lot of problems with the arrays in this. So I'm keeping everything in data frame until the last possible moment, which makes data operations a lot easier. So now we're scaled. We have Xtrain and Xtest. We need them split because the principal component analysis has to be trained on only the training set. We don't want the validation set to go into the PCA because it's kind of like cheating and you're going to get overfit. So, yeah, because essentially that holdout set is supposed to be, we've never seen it before. Our model's never seen it before. So I'm holding that out, right? So the PCA model is fitting only on X.train. We fit that PCA model. We extract the variance and cumulative variance. If we haven't done PCA before, extract the eigenvalues. And so, I essentially did 20 components. I ended up selecting 3 significant components. So we're going to have our 3 components. We're going to make predictions. So we fit up here. We transform the train and test scaled version. So we've scaled. Then we're on PCA. Then we put it back in the data frame again. Concat that back together and then re-index it. And then we can see the 3 principal components here. I like to have the PC 1, 2, 3, but it's just a little bit easier and to have it 0, 1, 2. So our principal component is our first one, second one, third one. So a lot of this work is based on the hyperparameter grid search.